All
Top of the
right.
hour. Go ahead.
Thanks. Thanks everyone for joining. This is our October meetup, Generative AI on AWS. Thanks everyone for joining us here. If you're joining us for the first time, special welcome. We're running these events every month. We're gonna have one more in November, and then Chris just pointed out we're gonna take a brief break in December. There's a lot of things going on, one of them being the AWS reInvent conference. So that always gives us a lot to talk about in January in the new year. But for today, we do have an exciting agenda and exciting speakers with us. Today, we're gonna talk about quantum artificial general intelligence. Super excited to hear more. We're gonna have multimodal chatbots and see a demo there. And we also have a GenAI startup here today that will share us a little bit more. And for the speakers, Chris and I, we're your hosts, super excited. We welcome today Jesse from, do I pronounce that right? Qamia?
Qamia. Qamia.
Qamia.
Yep, yeah.
Perfect. A quantum AGI startup. So I'm very excited to hear more about what you folks are doing there. We do have Danilo with us today. Danilo is a colleague of mine on the developer relations team at AWS. And Danilo will show us his demo multimodal chatbot. Super excited to see that. Thanks, Danilo, for joining. And we welcome Nitin today. Nitin is founder at Karini.AI and will also show us what they're doing in the startup world. Chris, what do we have next week? Just a quick sneak peek. Next month, sorry.
Next month, yeah, there's a new deep learning AI course that came out, I think, a month or two ago on data engineering on AWS. It's a long time in the making. It's a massive, massive course. It covers everything about data engineering and with the AWS spin. So we'll have the creator of that, Joe Rice, on, and we've got one other special guest that I'm going to keep a secret until, until they confirm, really. But yeah, otherwise I would tell you.
All right. And just a quick another update. Now, as you mentioned it, we just launched another short course with Andrew Ng and Deep Learning.ai just last week, focusing on building agentic workflows. I'm going to drop the link in the chat here just in a second. But if you're interested to learn more about agentic workflows, this might be a really good one to check out. All right, anything else, Chris? I think otherwise we're good to get started here with our first talk.
Let's do it. I'll drop the link in for that short course right here.
Perfect.
So it's
Perfect. Thank you. All right, Jesse, stage is yours.
Okay. Thank you. All right. Can everyone see that?
Yes.
Yes. Okay, great. Yeah, so I am from Qamia, and we are a quantum AI startup based out of the UAE, actually, and where there's a big, there's a bit in the chat about this, but there's a lot of focus on the UAE and other Middle East countries on they call it Vision 2030, and we're kind of riding that wave to build knowledge-based economies as opposed to carbon-based economies in those areas. And that gives you a quick summary. We focus on basically quantum and AI, which is a really large segment. I would say mostly we're focused on hybrid quantum and quantum artificial intelligence. And application-wise, right now, most of the focus happens to be on hybrid quantum because that's actually sort of the easiest to bring into production. So, but I have some things to say on quantum AI, and it's more, this is going to be, I think this is good to queue up in front of another Gen AI talk. And I want to be clear, I don't have enough time to give like a full talk. So I think I don't want this talk to come off as saying I'm against LLMs or anything. It might look like that if you look through the talk without me speaking. But what really is the key is that I think I love where LLMs have gotten to. And I will be the first to admit that I used LLMs, in creating this talk to look things up and do research. I use them if I want to stand up a Docker container and it can just generate a Docker file for me. Lots of Docker, lots of stuff. And so let me, but I think there are limits to it. And I think I want to use this talk as actually a little bit of a soapbox, is to say, hey, there are other ways out there that we could start looking at. And I want to just kind of bring that into the forefront here. This is about us. Rauf is a co-founder, and I am the other co-founder of qamia. I started my professional life at Target, actually building for recommendation engines, and also doing some of the first sort of multimodal AI that was out there. As far as I know, back in about 2014, we built a fashion recommender system using things like ImageNet and some of our clickstream data and on a Word kind of a Word to Vec platform way back when, and we brought it all together to create something we called Fashion Police, and basically it was attempting to recommend visually based fashion recommendations on what you were looking at online. So and we built it on a 4 GPU quote unquote cluster under my desk, and it was sort of fun to think about. And we eventually built it on the larger Target cluster too, but that was when you could just use just a few GPUs. And so this is where it's just a tongue-in-cheek current state of AI. But basically, the current state of AI, as I see it, is sucked up all the data that's available, and we've created some really amazing models. But they are really data intensive, and there's a certain paradigm that's being used. And I would love to hear about others as well. I know there are lots of tweaks on transformers and stuff, and I don't know all of them. But ultimately, the key is if you can get more compute, you can get a better model for the most part. Yeah, you can use various fine-tuning methods to make them better on specific data and stuff. But there's a finite amount of data, and ultimately it comes down to the fact that we are getting to be a bit limited on data, and I'm a skeptic on synthetic data, but I always have my mind changed on that. So. And I think the current AI is sort of this is what I think current AI is. Whenever I hit up a chatbot, I ask it something, and I say, all right, ChatGPT, give me an answer. And I imagine that it's basically like Grommet here, trying to get me an answer as quickly as possible. And of course, there are exceptions to this. There's a newer ChatGPT model out there that thinks a little bit and does some cross-referencing, I know. But I don't know what it's doing. It's closed source. It's from OpenAI, but still closed source. And ultimately, it's more data gives you a better guess, because you are just going to get an answer that as good as the data that you've sucked in and as good as the model. But it's not, it's not doing what we really want out of AI, I don't think. I think it was really awesome when the first ChatGPT model came out there and some of the early ones, and sort of blew people away, that you could come up with really cool stories that had the right tone. But in the end, I mean, we're still limited to this linear model of just pushing stuff out. It's not working how we think. It's ultimately just creating a probability distribution and finding the most likely next token to put in front of it, kind of at the end of the stream of tokens. And we all are familiar with Jan LeCun's little battles on X or Twitter, and he's So I would love to find an LLM that's smarter than my dog or my cat or whatever. So the current trends, and this is why I want to, I'm pointing out the current trends partly because I want to point people towards the fact that I really would like to get I'm on my soapbox here, and I would like to say, hey, there are other ways to do this that are not just brute force. And if we had a chance to go back and use the massive computation that we have now, but we had a slightly different model, how would that work? So right now, I do think, we write decent essays. I think creating boilerplate code is awesome. They are really, really good at pattern. These LLMs, or, I use LLM kind of, this is sort of a generic term. It's generative AI is really good at pattern recognition. So, and that was recognized recently with protein folding. So, I think that that's all legit. Now, and I think we've come a long way, but I also am worried personally that we're reaching a bit of a plateau. When we start standing up nuclear power plants to actually run the AI, I think we need to wonder, maybe the model is not correct if we need that much power. Maybe we could go back. My brain, as I point out a little later, our brains use about 12 watts per hour. That's pretty good, and we're still a lot smarter than these other devices. And I think we're saturated in terms of funding, because a lot of this comes down to how much money can you acquire to train one of these models, which costs, as we know, like billions of dollars for training. That doesn't seem sustainable. And I would love, I'm excited to hear what my colleagues have to say about GenAI after me, to see, where I'm wrong, because I think, I come at this from a certain point of view, and I'm trying to push people in one direction. But my prediction is that without new paradigms, we are going to need, we're going to kind of run out of investor funding. And I talk to investors about this, and, behind closed doors, or, maybe if they're in the right company, they say, yeah, I'm a little worried that AI is a great way to burn money right now. And that, and I think you have to be really careful about which way you're going, because I think, at some point, if your model is dependent on tons of data and tons of compute, and that's mostly how you get to the better answers, there's only a limited amount you can do after a while. So that's my soapbox. Now let's see if you guys, what you guys think about this. There's a great article that came out, or articles that came out, on our humble fruit fly, not to scale there. It's actually much smaller. But a fruit fly, I would argue, is in many ways a lot smarter, or at least more versatile and closer to AGI rather than any computational system we have out there. It does so much on so little. It can walk, fly, feed, process. It processes its food automatically. And there are other, and it does this on, depending on how you calculate this. I'm happy to, argue one way or the other, but a fraction of a percent of the parameters in Llama, right? That's pretty good. It's doing something right, I think, and its energy requirements are quite small. And so, this is the comparison of energy requirements, and this is in megawatt hours over in this chart. And I think once a company, sorry to call out the elephant in the room company, once you say that you're going to lose $44 billion, I don't know if that's, I don't know if there's a demand. I mean, I feel like there's probably a demand for what we are getting out of AI, but I'm not sure if there, if you can argue that there's truly if there's truly that demand, if they're willing to lose that much money. I mean, it seems like as an investor, I would be a little bit nervous to see that much going up in smoke. Or sorry, going up in a data center, really. So what's our energy limit, and how much are we prepared to invest, before people put the brakes on investment wise? And I think this is something that I've seen kind of pop up more and more lately in talking to people, and then on LinkedIn, which is, I don't know exactly, what kind of echo chamber LinkedIn ends up being. But talking to people in private, that people are getting worried about what's, these amounts. So before we kind of hit the AI winter, the GenAI winter, it would be nice if we kind of had a way, an off-ramp maybe. And so the next thing is, let me just say that here's a possible off-ramp. There are many off-ramps, there are many different architectures out there, and I think quantum provides one of them. Is it tomorrow's off-ramp? The answer is, I'll be the first to say no. The devices are not large enough, but everything we know theoretically shows that they will produce sort of the non-linearity necessary to have the expressivity necessary to represent complex meaning and complex objects. And what I mean by that is you don't have to show it 1,000 or 10,000 or 1,000,000 glasses of water for it to understand a glass of water, right? And so, right now we're a little bit stuck on just the brute force method. And there have been a lot of theory and a lot of actually experimentation on small systems showing that, if all else being equal, a quantum circuit can represent a learning paradigm with much more power than just kind of the classic artificial neural network. ANN being artificial neural network here. And so one thing, and I want to just point out that one thing that I focus on when I look at this, this field, and when I dive into quantum AGI or AGI in general, is what compositionality, which is it comes from NLP, but it's just like, how can you create a complex meaning from simpler objects? The sentences I'm speaking come from small little atomic words that create a much larger meaning. And that's one thing that if you have a probabilistic system and you're just trying to find the most likely token, you're not really finding the larger meaning, right? These devices typically know how to create, the most likely next token or the most likely next feature to pull out of the probability distribution. But we need a little bit more if we're going to actually kind of generate this expressivity. And so there are many ways to get there. And I think what's been shown lately is that there are the quantum circuits and quantum-inspired artificial neural networks, things that bring in the nonlinearity and the expressivity of the quantum circuits and what you see in quantum, being able to represent entanglement. And we can represent entanglement artificially. It's maybe not extremely efficient, but right now, I don't think anyone would argue that anything is very efficient in AI. And so moving to non-local, non-linear interactions, would be incredible to try to improve the sort of the complexity, that we're able to represent. And over here, you can see like what, there's a huge, just based on what actual quantum computer can represent, it's pretty awesome that, because you get this automatic parallelism, with qubits able to represent, sort of 2 to the n possibilities, the actual number of qubits becomes quite low for what you need to represent complex topics. And so I guess I will leave us there. I think we probably are even going over a little bit here. I think one last thing is I think a lot of people are obsessed with the singularity and the danger of it, which is our little HAL in the middle there. But I think like we have a lot of examples of what AGI could be, and really there are, if we can do this right, if we can create something as smart as our house cat that can understand its environment, learn where its water bowl is, learn when you move the water bowl and doesn't have to be retrained where their water bowl is, all these little subtle things that we just take for granted. And honestly, if I can have something that will do my dishes, that's really kind of where I draw the line. Where that's AGI for me, maybe. But in all seriousness, I think we're at the cusp of reaching a plateau with what we can do with brute force, and I'm excited to see where we're going to go when we're able to sort of step off of that onto a various paradigm, different paradigms. And with the brute force that we've sort of developed, I think one last thing is the brute force that we've developed with the transformer paradigm is really awesome because it gives us the brute force computational power to actually take additional paradigms and run with them. So that's yeah. And let me stop there. And I think I saw some questions come through, but my yeah, I'll stop sharing and see if I can see some questions here.
Yeah, so I actually have a question. Yeah, Jesse, so where are we in terms of the error correcting like qubits? And yeah, I remember studying this, and yeah, we had Rolf on a year ago or so talking about the state of things. So yeah,
so I'd say we're in a good state in one sense. Google came out with a paper recently. There was a lot of we're at the state in quantum where it's like we know what it should be, and then we need some experiments to say, oh, actually we can go there. So Google recently said, okay, we can go there. It said basically as you introduce error correction, you don't introduce sort of complexity on top of complexity. The error correction you introduce solves what it needs to be solved. So it could be that, okay, I'm solving error correction, but I need to solve more error on top of that, right? It could, and they showed, no, it actually scales fine. So meaning that once we could have sort of master error correction in terms of, 100 qubits or 1,000 qubits, that's not going to scale up like in some exponential way. We're going to be able to solve that. So that was actually very good. But in terms of where are we in terms of the fidelity of qubits, we're still at about 99.9 or so, meaning, which is not good. So when you actually, just raise that to the 10th power, that actually, so basically your qubits have that much error. But if you actually have sort of 10 qubits lined up in a circuit, that goes down pretty quickly. So we haven't reached, in terms of pure qubits, we haven't reached the right state. Now, error correcting will actually combine qubits. You might use 10 physical qubits for a logical qubit, right? And so we have a lot of so these are now abstractions on top of this. And I think one of the key things to point out here is the concept of the abstraction. Like there's still a lot of focus on like really close to the hardware stuff that we never work with in classical computers, right? But there's a lot of error on a classical computer. There's error in RAM, there's error on the CPU, and that's just been abstracted away. We don't even know it's there, right? And so we're kind of at this stage where people are working on the abstractions necessary. People are also working on just the raw engineering needed to make better qubits, and right on top of that, the raw engineering needed to kind of build in the error correction needed. So I don't know if that really answered your question, but we're making good progress, I guess, is the short answer.
Right. And I think is that the Google paper right there?
Oh, maybe, yeah.
Yeah, if folks wanted
Yeah.
to get started with quantum AI, Jesse, like what would be a good starting point? Like, is there a key paper, a good course? Like,
Yeah, I saw a course actually when I was searching. Let me look up a couple of papers. There's some actual survey papers, and I'll see what the most recent one is I can find. I'll drop it in there. There's one from a couple years ago, and things change a lot. But then again, things don't, sometimes, and so let me just see what the most recent one is out there and see who wrote it, and I'll put a couple options in there. Yeah.
perfect.
And I don't know of any. I guess a book would be great too, something. But if things change so fast, maybe that's not the best route.
Yeah, there's an O'Reilly book. I actually have it over here
Okay.
on my shelf that I can paste in here that
That'd be great. Yeah.
was pretty good. It, anything with O'Reilly has a really good narrative and good flow and things like that. So it makes sense, even if it's not, totally right.
And I think it's important to point out there's programming quantum computers, and there's then the kind of AGI portion. And there's sort of you got to kind of, if you jumped right into the AGI portion, there's a little bit of maybe whiplash. It's like, oh, I've got to go back and I've got to figure out, okay, what are we actually doing to kind of program these circuits? So I'll try to put up a couple links and stuff so we give people an on-ramp and stuff like that. So I like what you put down there. Programming quantum computers is perfect, right? And I think that's the first step. And then there's a whole course, maybe in quantum AGI, and see what we can see what's out there. Yeah.
I did a summer course a couple summers ago that was really good, where they had folks from industry and from academia that kind of went through the progression. It was pretty similar to the book. I mean, it ultimately ended up teaching me the same thing as the book, but it was nice to have kind of the background stories. So I think if you look up like quantum summer course, you might be able to find it there. Quantum summer school.
Quantum. Oh, nice. Yeah. Where was that? Was that just online or out of Stanford?
It was online. Also, IBM has the Qiskit summer school that they did again this year. So
that's a really good one. IBM has a ton of resources, and their Qiskit, they have like a graphical, like a GUI circuit editor, which is really fun.
Yeah.
You really get some good intuition from that. And then
that one's tough to get into, so you have to kind of keep clicking refresh every day to see when they're gonna actually put up the reg page. But yeah.
Oh, okay.
Okay, and I think we have to move on. There are one or two questions, but Danilo, are you ready to roll? Yeah, thanks, Jesse, so much.
And Jesse, if you have a few minutes and maybe tackle the questions that are in the chat.
For sure.
Thank you.
Cool. Yeah, take it away, Danilo.
Yeah, thanks. Let me share the right screen. Can you see the slides?
Yep.
Yes.
Perfect. So thank you for having me. I work in the same team as Antje, and because I'm learning a lot in this space, I like to run experiments. And this actually came out from a suggestion from Antje about exploring multimodality with more details. And I try to build something and try to explore what are the limits of the current technology. Compared to the previous session, my talk will be more down to earth, but I think it would be fun if you like building things. So the idea is I wanted to build this chat interface. And as I said, I wanted to build it multimodal. The reason for the chat interface is that, as many of you, the chat interface was the way I was exposed at first to generative AI, and it's, I think, a very interesting way to interact with computers. Let's explore how we can extend that with multimodality. So I wanted to be able to process images, to process documents like PDFs, presentation, Word documents, and even audio, will be able to produce audio conversations. I wanted to be able to do exact computation. So I wanted to run code and maybe have the model run Python code, be able to generate images, and these images can be generated from a visual perspective, or maybe you can generate charts or graphs using Python. And also I wanted to be able to use updated information. So I want to be able to browse the web, so search the web, search maybe some more authoritative sources like Wikipedia and research paper like Active. And also I always found this asymmetry between the amount of information that we can give in input to a model, now in the 100,000s of tokens now, and the amount of output that we can get with a single invocation. So I wanted to be able to use this interface to create long text like article, blogs, and potentially even a whole book written by this chat interface. And these were the things that I wanted to explore. And this is the resulting architecture that is very, very simple. So I have a web chat interface that has access to a text and a text-to-image model. And then this chat interface can use tools that can access the models, can access embedding models, and can use these embedding models to store text, to index text and images into a vector database. As you can see, I have two separated indexes here. I'll talk a little bit more about that later, but the idea is that multimodal indexes, I explored a lot of them. They normally cannot index a large amount of text in a single shot. And I wanted to go beyond that. So normally you have a limit around 100, 150 tokens with max size. And I wanted to be able to index a few hundreds of tokens easily with text. So I decided at the end to have two separated indexes. And the tool can manipulate the indexes and can store and generate and retrieve images, can output files like documents. There is a session memory to store some information, and they have, of course, access to the internet. So let's see a few examples of how this works. So this is the interface. It's not completely updated. So today it's a little bit better because I just recently updated everything to Gradio 5. I'm using Gradio for the web interface. And this is an example of how you can use this tool to search and browse the internet. So on the left is the web interface, and on the right is the log of what the tool is doing. The text is a little bit small, so I hope you can see it and you are able to zoom in. So let's start to ask, for example, can you compare two AWS services, Bedrock and SageMaker? And I explicitly ask to look at the product pages. So the model is now building the chain of thought of what to do, and then it's using the tooling available. So it's using the web search tool, it's using DuckDuckGo, to find the product pages of these two services. Then it's downloading these pages. And if you see the page length, for example, for Bedrock was 2 megabytes of pure text, then I clean this into Markdown and it's 176 kilobytes. And then I split this into chunks and index into the text index. And after it's indexed, I retrieve generic information based on the page title plus specific information based on the keywords that are passed by the model. And I only retrieve 20,000 characters. So from 2 megabytes, I only have 20K of premium content that is retrieved and passed to the context of the model. So this is a very efficient way and a very peculiar way of using a multimodal index. And then I do the same with the SageMaker page, and from 2.5 megabytes, I extract using the indexes just short of 20 kilobytes, and this is passed to the model, and the model is able to do the comparison. So it's using updated information from the internet websites. The next step was to go a little bit deeper into the multimodality. And because there are a few tools, we can start by asking to the model, what can you do with images? And this is an interesting question because it's using introspection. So the model is going to look into its own internal functionalities, and it's providing me an answer. Like I can search and retrieve images, I can generate images, I can display images and analyze images. So let's start with something a little bit easy. So I have a few images here on my hard drive. I pass these images following a long tradition of machine learning. These are only dogs and cats. And I ask to compare these images. So this is passed to the model. The underlying model here is Claude 3.5 Sonnet. But as the images are passed to the model, they are also indexed and stored. So the indexing work by creating a description of the image, and then the description of the image and the image itself is passed to the multimodal embedding to index based both on the description and the image content. Now I get the output of the model. It's doing the in-depth comparison of all these images. It's looking at the colors, the pose, the background, and it's giving me a very detailed description of how these images are. But now the images are also stored into the image catalog, and I can ask, for example, to show a random image. This is relatively easy because it picks a random point in the vector space and gives me a random image. And this random image is a dog playing on some grass. And now I can do more things with these images. So for example, I can ask to find two images that are similar to this one. So the images in the context is used by the model to do similarity in the vector space. And then the first result of the similarity is the same image. And then the second and third results are these two images of dogs, again, either playing or running or on a same grass background as the first image. So clearly the more similar images to the first one. Now I can ask to generate images of a dog and a cat. And let's make this a little bit funny. So we can generate an image of a dog riding a bicycle. And the model is creating the prompt from my initial input, is generating the image, and then is creating the description of the image. And then the image is stored and indexed as before. And so we have the dog on the bicycle and we have a cat on a car. So now we have a lot of images here. And they are stored, and I can do another kind of search using the text part of the multimodal index. So I can ask to show an image with a car, and there are a lot of dogs and cats, but there's only one car in the image catalog. So it's doing the search on the multimodal index. In the vector space, you always find neighbors, so I need to filter the results to check that there's actually the car as requested, and only one image is the one that contains a car and is shown here. So for text search, there's a pipeline with two stages, vector search, and then an LLM to filter results. So this was an example of what we can do with images. And the next step is to add a code interpreter. And I used, on AWS, we have the Lambda functions to run code in a sort of sandbox environment. So I'm using this to run Python code and also generate images. So I can ask how many prime numbers there are between 1 and 10, 1 and 100, and so on, up to 1 million. So this is generating a Python program. So the model decides, okay, I can use the Python tool to solve this problem. Is generating the code. There is an isPrime function and then some ranges where the model is going to look for the number of primes, and it's generating this table. What's interesting is that it has also decided to create an image, even if I didn't ask for that. And because the model understood that there is the prime number theorem underneath, it has decided to show this number of prime numbers, the number of prime numbers on a logarithmic scale, because in this scale it becomes a line, and it's also explaining the theorem behind this exposition. So it's quite interesting that from a mathematical request you get also an image without pointing it out. Next step is long text content. So in this case, I'm a little bit a nerd on the mathematical side, so I decided to go with asking for a multi-page article about computing pi with numerical methods in Python. And I asked also to run all the code and also produce outputs and visualization. So now the model is using another tool that I call for the model a sketchbook. That is it's a list of strings, and the model can write these strings one at a time, and these strings are exposed as a section to the model. And then it can review these strings one at a time. In this way, it can append and create very long content, much longer than it can do in a single shot. And it can then review and update the content by going through this list more than one time. And the output of this is a document that is written on disk as Markdown and also as a Word document. And this is the unedited output from this phase, because the tool that I'm writing is completely open source. The table of content requires to be updated to get the actual page numbers. There's a static table of content that we can remove, and this is the document that has been created based on those two lines. It's explaining the importance of P. It starts with Monte Carlo methods, shows the convergence and how it works, like sending points into a square and counting the numbers inside a circle. So then it's using the Leibniz method and showing the convergence. And finally, it's using the Chatnowski method, that is the most powerful method to compute pi, that has a very fast convergence. So it was quite a good document created just from 2 lines of request. And finally, I was quite impressed when Google launched the Illumina project. I think that was the closed version of what now is Notebook LM. So I immediately thought, okay, on AWS, we have access with Bedrock to models, and we have another service that is Amazon Polly that can create a very natural voice with generative AIs. So I try to connect the two things. So the idea is that anything that is in the context of the model can be turned into an audio conversation. So in this case, I ask, read the history of how Rome, my hometown, was founded from Wikipedia and put it into an audio conversation. So now the model is using the Wikipedia search. There's actually a page that is the founding of Rome. It's downloading that content, putting it into, indexing it into the text vector index, and then it's retrieving again only the important parts from this text, and then it's generating a conversation. The input to the tool is in JSON, and then the final lines that you see is when there is the conversion into audio using Amazon Polly. And the next step is actually the result. You should be able to hear the voice that is generated and also see a slightly different accent compared to mine.
Hey, have you ever wondered about the founding of Rome? It's such a fascinating story. Actually, I've heard bits and pieces, but I'm not sure about the details. What do you know about it?
Oh, it's quite an interesting tale. The traditional founding date of Rome is said to be 753 BCE. That's nearly 2,800 years ago.
That's right. And the legend revolves around twin brothers named Romulus and Remus.
Okay, we don't need to go through all the audio recording, but it's interesting that from a very small input, it can create a few minutes of conversation. And I made some improvement after I recorded this demo, so there's now also some prosody so some pauses that are being added automatically by the model to improve the flow of the conversation, and it's automatically deciding the number of people in the conversation between 2 and 4 people, and it has 7 voices that can be used, 5 US English accent, and then there is a UK English and one with Australian English accent. So it's quite an interesting conversation that then can be created. So this tool is using Gradio 5, just updated for the web interface. It's using a few AWS tools, so Bedrock to handle the conversation and tool use, and then the Titan text and multimodal embedding models. It's also using the Titan image generator or through Bedrock. You can also use Stability AI if you want. It's using OpenSearch for text and multimodal indexes. And in the version that I share on GitHub, OpenSearch is running locally on your laptop if you want. So there's no cost for the index. You can test it and you only pay for the use of the models. As I said, I use Amazon Poly for the voices, and there's a huge free tier, so you shouldn't go into paying unless you really generate a lot of voices. And AWS Lambda is used for the code interpreter to provide a sandbox environment between the different invocation to run Python code. So I have a few takeaways of this experiment that I ran. So first of all, now multimodal is still not easy because the amount of information that can be stored into a single item in a multimodal database is not big enough to store enough text compared to pure text vector index. So this is something that I expect is going to change very quickly. Maybe it's already changed in the last week and I still don't know, but it's something that you should care about. One thing that struck me is how you can work with external systems. So at the end, the model is used as an agent, and this agent is using a lot of tools. And because these tools can be external API, external systems, they can sometimes provide us unplanned return code, an error. And at the end, the things that work better is if you get an error, you feed it back and send it back to the model, to the agent. And sometimes the agent can fix itself. So for example, I was using a tool to generate a PDF from a document. And this tool was not supporting Unicode. And at some point, the model created one document with Unicode. It tried to convert it to PDF using the tool. It got the error that Unicode was not supported, and it updated the sketchbook that we saw to remove the use of Unicode, and it sent it back to PDF, and it solved the issue by itself. So I think this is an example of anti-fragility, the property of a system to be able to solve issue automatically. And I think it can have a lot of application, but the most basic one is really that if you use external APIs, sending back the error to the model and to the agent is the fastest way to hope for a correction. And the second thing that was interesting to me was the capacity of introspection of the agent. So the agent at the end knows all the tools that are connected, and it can talk and answer questions about the property that it has. Like I can do this with images, I can do this with audio files, and so on. This opens a lot of possibility beyond the pure chat interface. So for example, something that I'm thinking of is that because each tool has its own parameters, this introspection can be used to automatically generate a user interface for every tool based on the parameters that the tool expects. So it can really be powerful to self-adjust the user interface, maybe in a web interface. The last point is long context. So models now support very long context, and they work very well with long documents. But a strange experience that I got is that when there is a conversation with a lot of tool interaction, then it's easier to get hallucination, especially hallucination on tool use. So maybe if you use the same tool three times in a conversation, then there is the risk that the fourth time the tool is not actually invoked, but the model tries to reproduce the use, often making mistakes. Maybe that's due to the way I store the history of the conversation, but it's something that struck me as peculiar. And yeah, if you enjoyed this quick demo, all the code is available here in this repo. I don't use any external library. We built this to learn, so I'm only using the AWS SDK, and I built everything, the chunking, the storing, everything is built and implemented in code as a way for me to experiment and learn. Thank you.
Thanks so much, Danilo. This was great. What do you work on next? Experimentation.
Yeah, there's a lot of ideas, but the idea that I want to explore really is the concept of anti-fragility. So this idea that in any, not necessarily an AI application, but any kind of application, if there is an error, we now have a way to fit this error to something that can take corrective actions. It's definitely an interesting idea for me.
Yeah, absolutely. We don't have much time for questions here. Apologies. I want to be respectful. Chris, do you want to touch maybe on one question for Danilo?
I think maybe Danilo can just answer since we only have 15 minutes left, but there are a couple good questions in here. A big one was about cost. Like, I guess maybe you could address that one real quick.
Yeah, definitely. So as I said, no, the only cost here is the cost of the model, and everything that is not creating very long content is relatively cheap nowadays in the sense space. If you generate a document, then you can go into the single-digit dollar cost. So if you create a 20, 30 pages document, then you pay $1, $2 in terms of APIs. That's all the cost that I have that I experienced.
And it's all serverless, right? You're using OpenSearch serverless.
No, I'm using OpenSearch locally. It's a poor man implementation. So I run it locally on the laptop, and in the repo I have instructions to run it using Docker Compose or similar tools like Finch. So the only cost is really the embedding and the model. Embeddings, again, they don't cost much. So to go into single-digit dollars, you need to process millions of tokens.
Gotcha. And I actually ran yours in my personal account recently, so I can actually go look at the cost because I don't have anything else running in there. So, so let me go look at that. I could post it in the chat. Nitin.
Danilo, yeah, if you could just check maybe a couple other questions in the chat. There was something about the indexes, text and multimodal.
Okay, let me.
Thank you. And then we hand it over, to Nitin.
Yeah, go ahead, bud.
Yeah. Thank you. Thanks, everyone. Thanks for being patient. And hopefully, now I have only 12 minutes. Try to rush through, but feel free to hang on. I have a cool demo at the end. And Danilo and Jesse, amazing topics. We do a lot of multimodals. We also have cost and everything baked into the product to build a production workflow. Awesome. So we are Karini.AI. Our slogan is don't build platform, build use cases on AWS because we are that GenAI foundation. AWS provides you enough of tools to build use cases. So a bit about myself, I'm ex-AWS, worked with Chris and Antje in the past when I was a part of SageMaker team. And I went to Databricks, led I think launched 5 products for GenAI, and now I'm leading product engineering at Karini. So I'm going to give a quick intro into Karini.AI, talk about GenAI Foundation on AWS, how Karini can become that foundation for you and customers, AWS customers, the use cases that we address, and then I have really cool demo of contract review agent. I think we have covered quantum, then brought it down to multimodal, and then I'm gonna even dump it down for like business users, how they can use like a contract review agent and really cool chatbot for draft mode. Okay, so let's get started. So what we have seen, quick 3 challenges to make GenAI productionize in customers' environment. So first thing is a lot of projects are stuck in POC due to lack of quality. You don't get business approval. Then when you go to production, deployment of production itself is different than POC because you need to add a lot of bells and whistles, and I will talk about them. So customers are very cautious when they go to production. And finally, there are not enough, I would say, Danilos and Jesses in the world who could like do production grade GenAI. So there is still barrier to entry for a lot of enterprise customers. So how we tackle that. Now, this is the simple compound GenAI system in production. As you can see, there are a lot of these blocks, and all these pink blocks are typically model calls. So this entire system needs to work in cohesion. If one of these things fail, it means like bad response or no response at whatsoever. And typically, when you do a POC, you look at probably creating some sort of vector store, and then you build like a simple chatbot that does like a simple things. But then when you go to production, there are many things that comes in play, like guardrails, evaluation, semantic memory, detection, follow-up, etc. So with Karini, we solve for all of the challenges very, very easily. Now, quick value prop, build quick high quality POCs or MVPs in 30 minutes, of course, on a skinny data set. Then you check few boxes, you can deploy to production with confidence because it's a well architected chain for each of the use case. And then the product is really low code, no code. So it's good for, of course, advanced practitioners because they can get away with a lot of these things without having to write code. But then they can still observe responses. They can still observe, their sketch pads and whatever tools they're used to use. And then for beginners, it's a really good tool for like up leveling, upskilling your workforce, and also conducting training workshops because you can see instant gratification. So let's come to GenAI Foundation. What is a GenAI Foundation? So as you can see here, this is the AWS way of presenting a generative AI stack, right? So we literally borrowed that slide and then created our own version. So as you can see in the purple blocks, that's a unified GenAI platform that is Karini.AI, which provides a bunch of capabilities in a unified way. You can build a GenAI application from data to application and then manage and monitor it. We are built on top of course, AWS services. We are hosted on Amazon EKS. We have a SaaS as well as customers deploy in their private VPC on EKS. We also use a bunch of other AWS services, like my favorite SageMaker for GraphRag processing, TextRack, Comprehend. And then for LLM inference, of course, we are married to Bedrock, and you can also build like custom models through SageMaker. Now Bedrock also provides that. But then we also sort of can connect to third-party model providers because as a customer, you want to have a choice. So other model providers from other clouds, as well as private model providers. And you can build any of these use cases on top of Karini AI platform. And every customer that I've worked with, like mostly enterprises, they try to build a similar platform. Takes more than 12 months and average that much time and effort, and it becomes accelerated. It's not a product, right? So we move fast. Some of the use cases that we solve for, of course, the RAG, agentic RAG. We also support multimodal. So anything with multimodal, as long as your agent can support it, we support that, right? And the agents can be easily built on Karini. So RAG, agentic RAG. One of our first customers was actually an IDP solution, and we have re-platformed that to make it more agentic. And then generative BI is, I think, the highest TAM in the market. So you can talk to your databases or data warehouses through GenAI. We support, I think, 8 or 10 databases and data warehouses. And then the current trend is knowledge graphs and multi-agent, and that's what we are going to use for the contract review workflow. Awesome. So the platform itself this is like a life cycle of a typical GenAI project. It's an infinity loop. You start with access to models on AWS. It's Bedrock or SageMaker. Then we have a prompt engineering, unified prompt engineering experience where you can author, compare, and then record experiments. Most of our work in prompt engineering happens, the work for GenAI happens in prompt engineering experience. You can build like agentic, multi-agentic prompts, then bring it to our no-code canvas, where you can build knowledge base when you go to production, knowledge graphs through Neo4j. Then you can build agent, RAG, and different type of architectures using no-code interface, what we call as recipes. You can evaluate them. We also have LLM as a judge for evaluation. Then you can deploy them as, we call it Copilot, but this has nothing to do with Azure. It's purely like, we like the name. We might change it in future, but you can build chatbots literally by filling out a form. You can export them as, let's say, a Teams application that we are building currently. And you can provide like fine-grained feedback. Then we have our own open telemetry database and then tracking database that tracks every model call, displays them. So it's really good for troubleshooting when you're doing, let's say, red teaming internally. You can use that feature for tracing, what we call as tracing. And then slice and dice the data, find outlier responses, maybe correct them through the UI, take them back for fine tuning to Bedrock, or of course, choice of your system. There are a lot of them for model alignment, and then bring back that improved model, and then it's a virtuous cycle. So it continues. So very easy to go from production to experimentation and experimentation to production. Okay. Awesome. So now let's jump to the use case, and I'm gonna quickly get to the demo and show you how the demo was built, and then also the end user experience. So, so as everyone needs contracts are like quintessential in every business. Of course, every customer has some sort of legal provider, or a lot of people internally who have done this. They have like a lot of knowledge about the business, become these contract experts. So, but with GenAI, everything has become easy. Language is that barrier has been broken, and now, but how do you make that GenAI make work for your own domain knowledge, your own like private knowledge that sits behind your firewall? That's what we are building with this contract review workflow. Okay. There are two choices we had to make. One is we could always use like knowledge base that I think Danilo was saying OpenSearch. So we do support OpenSearch out of the box, which is a knowledge base of choice for us. But then we also support knowledge graphs. The nice thing about knowledge graphs have typically these nodes and relationships. Again, this slide was borrowed from Neo4j because we support them out of the box. But they're really awesome because you can pre-create these knowledge graphs using LLM, and that's what we do. And then you can store them as nodes and relationships. So, and then you can ask like really complex questions, which typically are not possible for a flat database like OpenSearch to provide, right? Like multi-hop questions, semantic reasoning. And we use knowledge graphs for this contract review workflow because it can then parse clauses and different elements of a contract and then store like sort of standard contracts in knowledge graph. So next set of contracts that you want to write, it can provide that information. Awesome. So this is the architecture. We took there's a open source database called Quad. We took like the franchisee contracts. That becomes our ground truth. We did OCR PII with AWS services, did a graph extraction, created the embeddings wherever appropriate in that graph, and then sort of stored them in Neo4j database. Now, on the query side, a user uploads a contract draft, or they can start fresh with a new contract. Then they can perform different types of operation, right? Changes, risk assessment, rephrase a particular term, add a new term. So whatever is typically needed in a contract authoring can be done. And this is an agentic architecture that you can build through Karini. Of course, we dumbed it down for the demo. So what it has is like, the agent starts, it has a router node, and routers are amazing. They sort of cut all the, I would say BS by providing a direct path. These are like API gateways, but more agentic. More LLM driven. So there's a parser chain, which parses the contract, reviews it, provides feedback. And this is where it refers to the knowledge graph through Neo4j tool. Another path is I just want to enhance text, and then I want to ask questions about that particular contract. So these are like three routes here, but we wanted to keep it simple. You can make it as complex as you want, and it'll still perform. What we found was, as we switch to this new architecture which is router based, this provides like lower latencies compared to like our other tree-based approach of agents. So definitely, if you are up for it, sign up to our product and in SaaS, and we'll enable you to test it yourself. So now with this, let's jump to the demo. So I'm gonna switch screens, and I think we are at time, but I will hopefully finish this in like next 5-10 minutes, and then please, you will have the recording as well. Okay, so can you see my screen?
Yes.
Chris? Awesome.
Yes.
Awesome. So this is our SaaS UI, and then as you can see, these are the dashboard where you can see at high level, like what is the cost by different endpoint, different chatbots that you have built. We also support batch workflow, and then like a leaderboard here. Now, so I'll just talk about so quickly, there are different menus here. The relevant one is, of course, you have the model hub. This is where you register embedding or language models. These can be also multimodal. We support audio, re-rankers, LLMs, and then of course, vision models. All of them are supported. You just have to register them here. And then this is how we also scrape pricing. So you also get like pricing out of the box. If you build an application, you will totally understand real-time pricing, what it is cranking or not cranking. Then we have a prompt playground. This is where, sorry for that. Yeah, so this is a sandbox. It has like lot of things. So this is where you can like build these prompts. We can build agentic prompts, simpler prompts, and we have a bunch of prompt templates available. And you can also test and compare side by side of different prompts. Then this is a prompt playground. Then another bit is recipes. And this is where, as you can see, there are two types of recipes in contract workflow. There's a GraphRag recipe. So I'm just gonna filter by GraphRag. So recipes are like, just imagine these are like GenAI projects. Recipes can be used for creating a knowledge base, creating an agent, and then quickly testing it before you deploy to production. Okay. So let me go to GraphRag. Awesome. Let me see. Okay. I'm gonna, let me see, where is that recipe hiding? Okay, I'm just gonna probably show you this one, right? This is like another recipe that we have built. So it's very easy. So you can see this is a GraphRag recipe. Everything is like drag and drop. We kept it intentionally very simple. A lot of these styles are simple on the knowledge base recipe so that you can quickly get this out of your way. So as you can see here, there's a source database set. It's all in Amazon S3, but you can use whatever sources are possible within Karini. It can be Box, Dropbox. Soon we'll also be integrating with Amazon Q, so that we just want to outsource all the knowledge base creation to Amazon Q. But anything complex like GraphRag, we'll still support. Then through our data set, you can then do OCR and PII. So depending on the choice of your engine, let's say I want to use Amazon TextRack, you can use Amazon TextRack, extract tables. This is really awesome for creating multimodal chatbots as well, because from your input data set, let's say product manuals, you can extract tables, images, and then store them separately in separate vector indexes. Now this is knowledge graph. Then next thing is, after the documents are OCR, let's say these are judgments, then you can run what we call as a metadata extractor. And through metadata extractor, this is where you can extract nodes and relationships. And then, and finally, it becomes a knowledge base within your knowledge graph, which is in this case, a Neo4j. Now, the important piece to this knowledge graph creation is descriptors. So we also allow you to create descriptors directly using LLM. So we have a descriptor functionality, which takes random sample of your source payloads. It then provides a recommended graph that you should use for your use case. And then as a domain expert, you can come here in the view descriptor screen. And this is where you can then augment, because you have a domain knowledge, and you can augment, okay, let's say this is a contract node. These are the properties. These properties, we recommend, okay, you should have a text index. And then for the provision, you should have a vector index. So this is the power of Neo4j, because Neo4j, you can have multiple nodes and its properties, and each property within that particular node can have either vector index, where you can use semantic search, or text index. And then you can, as a domain expert, you quickly figure this out, save the change. You can also download this so that you can export and import a new project. And then once this is done, then you run your graph export, graph recipe, and then your knowledge graph is created. Now, this is the underpinning. Now, second piece to this is, I'm going to discard this change, is the actual contract workflow. So I'm going to go back. And I have different agents here. Let's see, contract. Awesome. So this is the contract agent. So this is our sort of agentic workflow. So this is a different type of recipe. And as you can see here, it provides you a bunch of building blocks to create agentic workflow. And these are like graph agents. So you can build like very complex things here. So this is like a start node. Then it has like a router node, and that router goes through three different paths. And router is also an agent. Router is also a prompt. So LLMs are really good at like understanding your intent, and then passing that, passing that to appropriate next node. And then I have 3 nodes here. There's a parser node, which is like literally parsing the contract. Similarly, how I parse in the knowledge graph. Then it has a reviewer agent, and then reviewer agent has like these two tools, Neo4j, and then a legal text enhancer. So this is a reviewer path. So first thing, I upload a contract, I review it. Then I may want to look at particular section within the contract and then enhance the text. Again, we have just done through a simple prompt, but imagine this can also feed back to the same tools, so that you get like grounded responses. And finally, you can also ask like Q&As on that particular agent. So awesome. So this is how you can build. Very easy to build. You can start, add connectors. You can also add like processing. So I think Danilo was doing a demo, right, where you upload documents through chatbot. So we also support like inline processing as the documents are uploaded, so that when it reaches to the agent, it has the raw context. It can be, let's say, image to text. You can do PDF extraction, so that the agent itself has a core text or text summary when they work against a particular task. Okay. Now, you build this agent, publish it, and then you can export it as a chatbot. And as you can see, to build a chatbot, all you have to do is you add the whatever name, message, styling. If you desire like positive, negative response, you can add like custom feedback. And then since this is a draft mode, you also want to add like different skills that you want a user to use to interact with AI, right? Because these are typically business users, and you don't want to like sort of you want to totally dumb down this experience, but then it still needs to be grounded, right? So we have add like a review skill. This is an actual rephrase action, and like a ask a question action, and then that's it. And then you deploy. Once the chatbot is deployed, you go to the Copilot, and there are a bunch of chatbots. So this is the draft mode, as you can see here. There are chat mode and draft mode chatbots. And this is what the interface looks like. As a business user, I come back here. Let's see. I'm trying to find, okay, this franchisee agreement. I uploaded my agreement here. Okay. Agreement is uploaded here. I can see my previous documents. It's doing a little bit of processing here and demo gods. Let me go back to the contract that is already processed. Maybe this one. Okay, so this contract is already sort of processed, so we can just work with this. So I have like, let's say this text here, and then I want to change this, right? Okay, let's me rephrase. You know, I can also sort of change the prompt that I want to pass, and then it goes back to that agent. It's now sort of rephrasing. Hopefully, it has taken a rephrasing route, and it gives you the change text. You can see the changes. Okay, I like this change. I'm gonna accept it. This is good. Okay, it also gave me some comment. I can resolve this comment. Let's say I want to add like a termination clause. This is missing. Okay, I'm just gonna say termination clause. Okay, give me standard termination clause. I'm gonna right click, rephrase. Give me termination clause, rephrase. And I'm just showing you one skill, but you can add like a lot of things. Okay, looks like gave me some clause. If I like this, I'm gonna accept it, delete the whole thing. And of course, you can just author it as if you are authoring in the Word document. Now let's say I wanna go and ask question. Let's see, we have added a lot of buttons here, but just bear with me, ask questions. Yeah, now let's say I wanna summarize. Okay, hey, summarize the contract for me. Okay, now what it'll do is the agent will take a different route, which is like ask Q&A, and then it'll give me a summary. So as you can see here, this is the future, right? This is how I think Anthropic has released Canvas. OpenAI has released, OpenAI has released Canvas, and Anthropic has Artifact. So we borrowed a lot of these ideas, but we wanted to create something that is more grounded to your data, and also allow you to customize this experience. Now I can also export this as a Word document, send it to another party, and then they can probably see all my changes. And then the awesome thing is you can quickly interact, create these contracts. Everything is grounded, and then it still gives you the same experience as you would otherwise get through your traditional Word document or other mechanisms. Okay, so this is a quick demo I wanted to give. So let me go back to slide and close this out before we lose the audience. There are a lot of cool use cases that you can build. Of course, request for proposal. We have another webinar that's coming up. Blog authoring, insurance underwriting. So wherever documents are being authored or sort of reviewed through human, this chatbot can help you add the AI augmentation. So with that, I would like to close out. These are some of the value prop that Karini has. Of course, you'll have this recording, but we are all about productionizing generative AI for enterprises. Of course, you can experiment, but then also quickly productionize chatbots or also batch workflows. So with that, Antje and Chris, I will hand it back to you.
Yes, thanks so much, Nitin. That was an
Awesome.
awesome demo and presentation.
So, any questions I should take?
Yeah, let me quickly scan through. I think we had a question around the knowledge extraction part. Graph extraction can be a really kind of a complicated process. Any tips for that part?
Yeah, so graph extraction is the one complicated process. What we have done is that for that extraction, we have provided something called a graph extractor. So the whole knowledge graph, you know, the descriptor that you saw, graph rag. Let me just go to quickly a graph rag recipe here. Let's look at this one. Oops, wrong one. Sorry. Graph rag. We have a lot of them. Okay. So we have these types. Okay, let's go to this one. Yeah. Yeah, so what we have done is we have this thing called generate descriptor, and this totally dumps down. So what we do is with generate descriptor, we use the LLM to extract random sample documents. We have some heuristic that sort of provides, hey, what are the commonly occurring nodes and relationships? And we provide that as a recommended nodes and relationship. But then as a domain expert, this is really an area of domain expert who understands the data. For example, we are working with another talent acquisition platform who wants to use knowledge graphs, but then they have people who understand what are the different skills, what are those nuances of the skills and CSAT rating that they should use as nodes and relationship. So that's why we have provided this view descriptor schema, and I would use this approach because you still want your graphs to be predictive, right? There are two approaches, I think. If you follow GraphRag, one is that Microsoft approach where it's expensive and it's it's a little bit unpredictable, and we have much more deterministic approach. Okay, so this is where you would spend most of your time, like finalizing your descriptors, nodes, and relationships. So, any other questions?
Someone's asking about,
one?
yeah, the insurance use case. Can you elaborate a bit more on that?
Yeah, so that is just art of the possible. So let's say an insurance agent, right, who's responsible for underwriting or claims processing, they may have to look at documents submitted by their customers. So with the draft chatbot, we can like build an agent that does auto review of those documents and then provide them inline suggestions rather than something that they just like ask Q&A, right? I mean, traditional chatbots are I'm asking Q&A, or they are very much batch processing. Here we are talking about like sort of an interactive document review. You upload documents to the chatbot, it does the auto review on the upload, and then they can sort of go through it, resolve, and then also interact. So that is the use case for insurance underwriting or claims processing. So we'll have these sort of demos ready in like next month or so.
Sure. I'm curious, what is the stack that you built this on? Like, is this React? I'm just curious, like, there's probably some of us in the audience that are like, I could build this, but
Yeah.
I know you mentioned, yeah, somebody else had spent 12 months building something like this, and it's not like this. So
yeah,
just
this
curious.
is a really complex stack. Of course, the front end is all the latest technology, React, Next, whatever, our UX engineers. So it's a variety of things. And then backend is entirely Python, but we are like scalable. It's very easy to build like a toyware. It's very tough to get it productionized, right? And we are all about productionizing these workflows, and it comes with like all the AWS tenets like availability, reliability, and then also the coverage of use cases. So I've seen like many enterprises trying to build a similar platform, and they have built accelerators, or sometimes there's like this phenomena called death by use case, right? So you like over engineer on one use case, and then when you hit the next one, you have to re-architect, right? So this is a good balance between not over engineering, but giving you enough so that, yeah, you can build.
Gotcha. And I love the fact that you could see cost in here.
Yes.
I know that's trickier than it seems. So
It is very tricky, and especially things like guardrail. There's a lot of hidden cost. So let's say you use a guardrail, right? And we support Bedrock guardrails. So we have dashboard for Bedrock guardrails. Then we have dashboards for, and cost is everywhere. You go to, let's say, a guardrail page. Hopefully you'll see. Yeah. So I mean, yeah, there's nothing that happened here, but hopefully something daily, monthly. Yeah. So you see cost, right? So cost is in every page. Like you go to model page, you can see the cost, because observability in cost is very, very important to us. Okay. And this is where, engineering comes in the picture, right? Because everything that's here is logged into a tracing database. And then those traces have, and we also look at scrape all the cost and pricing from different cloud providers. And then we provide them, we marry them together, and that's how these are presented.
And now this is running, so this is a pure SaaS that runs not in the customer's AWS account, but inside of your, and so I assume that there's, multi-tenant isolation and people can't.
Oh, that's a good question. Yes. So this is a multi-tenant SaaS. So currently we are still going through the SOC 2 and other compliances. So we don't want to be responsible for customers' data. So what we do is we are onboarding customers to do POCs quickly, because it's very literally, it takes 5 minutes to provision something. There's no provisioning. It's literally, you create like a tenant space within a SaaS, and then you can start building things. And that's how we are able to get faster. But when it comes to production, it's everything is Terraform. So what we do is we typically deploy in customers' VPC, and it takes around 30 to 45 minutes. Most of the time it takes is provisioning EKS cluster. Otherwise, application itself is so easy to build. So it's all Terraform, and we deploy production application in customers' VPC.
Oh, you do? Oh,
Yes,
gotcha.
yes.
Okay.
For example, we are working with a customer. It's a supply chain customer, and they had built a similar system, like a batch workflow through IDP from a like SI partner. And now we are helping them re-engineer this, because what they want is, and their original plan was, hey, I want to deploy the cloud formation in each tenant account, and that's how I would onboard a distributor. With our platform, it's super easy, is because we already are multi-tenant. They're going to start with like one architecture, like agentic architecture. This is both IDP as well as intelligent document processing, as well as like chat interface. And then they can just replicate templatized similar architecture using our multi-tenant platform. Just onboard a distributor in like a new workspace within Karini, and then just connect AWS resources.
Right. So you're using the Databricks model, sort of deployment model, which makes sense because
Control plane,
we're at
data plane,
Databricks.
right? Yes.
Yeah. So separate control plane, separate data plane. And I think this is extreme. I mean, it's an extremely difficult architecture to build and to maintain, but I think it's absolutely critical for these data and these AI focused startups to be thinking about that. We're starting to see, I think even folks like Hugging Face and such are starting to look at some of those types of deployments. So awesome. Okay.
All right.
I think that's it, Antje, right?
That's it. I posted again the link where you can find the recording, and looking forward to see you next month.
Excellent. Yeah. Bye, everyone. I'll see you next month.
Bye-bye.
Thanks, everyone.
Thanks, speakers. Thank you.
Bye.